Example 11.5. Calculate the heat required to convert 3 kg of ice at minus 12 degrees Celsius kept in a calorimeter to steam at 100 degrees Celsius at atmospheric pressure. Given specific heat capacity of ice, that is 2100 joule per kilogram Kelvin. Specific heat capacity of water 4186 joule per kilogram. Latent heat of fusion, that is for ice 3.35 into 10 raised to 5 joule per kilogram, and latent heat of steam, that is 2.256 into 10 raised to 6 joule per kilogram. Okay. Now see given data: mass of ice 3 kilogram, specific heat capacity ice 2100 joule per kilogram Kelvin, specific heat of water 4186 joule per kilogram Kelvin, latent heat of fusion of ice 3.35 into 10 raised to 5 joule per kilogram, latent heat for steam 2.256 into 10 raised to 6 joule per kilogram. Now here be careful. We want to convert ice. Which one is at minus 12 degrees Celsius? To steam, which one is at 100 degrees Celsius? So in this entire process, 4 stages will be there. Be careful. First stage. So in that, the amount of heat absorbed by ice that will be utilized to change the temperature from minus 12 degree to 0 degree. Then second stage, the amount of heat absorbed by ice that will be utilized for melting. So now ice will melt from 0 degrees Celsius to water at 0 degrees Celsius. Then after, the temperature of water at 0 degrees Celsius will increase up to 100 degrees Celsius. And then after, the water at 100 degrees Celsius will be transformed to steam at 100 degrees Celsius. Now, Q, the total amount of heat required to change ice from minus 12 degrees Celsius to steam at 100 degrees Celsius, that we want to calculate. First stage, Q1, suppose. That is the heat required to raise the temperature of ice from minus 12 degrees Celsius to 0 degrees Celsius. So we can write Q1, that is Mi, mass of ice, specific heat capacity of ice, and change in temperature of ice. So Mi3 Si2100, change in temperature. Final temperature is 0, initial is minus 12. So final minus initial. So 0 minus minus 12. Now solve this one, you will get Q1. Then suppose Q2, that is the heat required to change the ice at 0 degrees Celsius to water at 0 degrees Celsius. Means to change the state. So Q2, that is mass of ice and latent heat of fusion for ice. 3 into 3.35 into 10 raised to 5. This much joule. Then suppose Q3, that is the heat required to raise the temperature of water at 0 degrees Celsius to 100 degrees Celsius. So Q3, that is M water, S water, delta T. So M water obviously 3 kilogram, S water 4186 delta T. Final temperature, that is 100, initial is 0, so 100 minus 0. Solve this one, you will get Q3, this much joule. Then suppose Q4 is the heat required to change water at 100 degrees Celsius to steam at 100 degrees Celsius. So Q4, that is mass water, latent heat of vaporization now for steam. That is 3 into 2.256 into 10 raised to 6. This much joule. So total amount of heat required to change the ice, which one is at minus 12 degrees Celsius to steam at 100 degrees Celsius. That is Q1 plus Q2 plus Q3 plus Q4. Take the summation of all these, you will get the answer. Clear to all of you?